You are sitting in a comfortable room, perhaps holding a glass of water, breathing in a steady rhythm, completely and blissfully unaware that the planet beneath your feet is actively running through a rather comprehensive checklist to end your life. We tend to think of Earth as a sanctuary, a perfectly balanced terrarium floating through the cold, dead void of space. We look at a blooming sunflower, a puppy running through tall grass, or a golden sunrise, and we feel a profound sense of security. But this perception is a trick of our incredibly short lifespans. Earth is not a finished product. It is an active, chaotic, and highly experimental laboratory. And the truth is, this rock has been trying to kill everything on it for about 4.5 billion years. If you want to understand the sheer scale of the danger, you have to start by looking down. About 1,800 miles beneath the floorboards of your house, the solid rock gives way to a churning, roiling ocean of liquid iron and nickel. This subterranean sea is heated to nearly 5,000 degrees Fahrenheit. In some localized pockets, the temperature down there actually exceeds the surface temperature of the sun. This liquid metal doesn't just sit there. It boils and churns in massive convection currents, driven by the heat of the inner core and the rotation of the planet. And as this conductive fluid moves, it acts like a gigantic dynamo, generating an invisible magnetic field that bursts out from the poles and wraps the entire planet in a protective cocoon. This invisible shield is the only reason you are currently drawing breath. Without it, the solar wind, a continuous, violent stream of charged particles blasted from the sun at over 1 million miles per h-hour would have stripped away our atmosphere billions of years ago. If you want to see what a planet looks like when its core cools down and its magnetic field dies, just look at Mars. Mars used to have rivers, lakes, and a thick atmosphere. Then its dynamo stopped. The magnetic shield collapsed, and the sun simply sandblasted the atmosphere into deep space, leaving behind a frozen, irradiated desert. We are separated from that exact same fate by nothing more than a geological heartbeat. But here is the unsettling part about our magnetic shield. It is incredibly glitchy. It is not a permanent, fixed structure. It shifts, it weakens, and occasionally, it completely flips. Over the last 83 million years, scientists have calculated that the magnetic poles have reversed at least 183 times. That is an average of one flip every 450,000 years. Though the timing is wildly unpredictable, during a reversal, which can take anywhere from a few centuries to over 20,000 years to complete, the magnetic field doesn't just neatly swap sides. It splinters. It weakens dramatically, sometimes dropping to less than 10% of its normal strength. The last time a full reversal happened was roughly 780,000 years ago, which means we are arguably overdue, and we are already seeing the cracks. Right now, hovering over Brazil and the South Atlantic Ocean, there is a massive weak spot in the shield known as the South Atlantic Anomaly. It is growing larger and weaker every single year. When satellites pass through this zone, the lack of magnetic protection means they are bombarded by intense cosmic radiation. Their computers frequently glitch and have to be rebooted. Astronauts aboard the International Space Station have reported that when they fly through this anomaly, they see sudden, inexplicable flashes of light, even when their eyes are completely closed. That is the physical sensation of high-energy cosmic rays shooting directly through their skulls and striking their retinas. If a full magnetic reversal were to happen today, the consequences would cascade through our modern world in ways we are entirely unprepared for. The global electrical grid, which was designed for a stable magnetic environment, would be overwhelmed by massive geomagnetically induced currents. Transformers would melt down. Satellites would die in droves, taking global communication, GPS, and financial networks with them. And the biological impact would be staggering. Entire species of migratory animals, birds, sea turtles, whales, that rely on the magnetic field as an internal compass would suddenly find themselves hopelessly lost. Salmon would forget how to find their spawning rivers. Bees would be unable to navigate back to their hives. And every living thing on the surface would be exposed to a dose of cosmic and solar radiation that the biosphere hasn't had to deal with in nearly 1 million years. But you don't even have to look deep underground to find the planet's violent tendencies. Just look up. The atmosphere you are breathing right now feels gentle, maybe a little breezy on a spring afternoon. In reality, it is a thermodynamic engine capable of unleashing the most destructive weather in the solar system. Consider a mature hurricane. The amount of energy a single hurricane releases through cloud and rain formation is roughly equivalent to a 10-megaton nuclear bomb detonating every 20 minutes, continuously for days on end. We have recorded tornadoes on Earth with wind speeds exceeding 300 miles per HR faster than any sustained wind ever measured on the desolate surface of Mars. And then there is the lightning. For a long time, we thought lightning was just a massive static shock. But in recent decades, NASA satellites looking down at Earth detected something completely baffling. Brief, intense flashes of gamma radiation coming from the tops of thunderstorms. These are called terrestrial gamma ray flashes. The energy in these flashes is so extreme that it literally tears the fabric of reality for a fraction of a millisecond, creating actual antimatter. Your sky is routinely manufacturing antimatter in the middle of thunderstorms, and you have spent your whole life walking around under it, completely oblivious. Yet, for all the cinematic terror of tornadoes and hurricanes, the atmosphere's most efficient killer is entirely silent. Heat waves are the deadliest meteorological events on Earth. The 2003 European heat wave killed over 70,000 people. The 2010 Russian heat wave claimed another 56,000. And the terrifying truth about heat is that the air doesn't need to literally catch fire to kill you. It just has to break the laws of human thermodynamics. Your body cools itself through the evaporation of sweat, but there is a strict mathematical limit to this biological trick, known as the wet bulb temperature. If the air temperature hits around 95 degrees Fahrenheit and the humidity is at 100%, the air is completely saturated. Sweat can no longer evaporate. At that precise moment, your body's cooling system shuts down. Even if you are a perfectly healthy adult, sitting perfectly still in the deep shade, drinking unlimited amounts of ice water, you will die within a few hours. Your core temperature will inevitably rise, your proteins will begin to denature, and your organs will essentially cook from the inside out. Climate scientists are already recording brief spikes past this exact threshold in parts of the Persian Gulf and South Asia. Then, of course, comes the rain. We write poetry about rain. We sing in it. It is the beautiful, life-giving elixir of the world. It is also the ultimate eraser of worlds. Give water enough time, and it will eat a mountain range for breakfast. The Appalachian Mountains on the eastern coast of North America were once towering, jagged peaks that rivaled the Himalayas in height. Where did they go? Wind and water systematically ground them down into the rolling, gentle hills we see today. The Grand Canyon, a chasm, a mile deep and up to 18 miles wide, is nothing more than the physical record of a single river being incredibly stubborn for 6 million years. Earth's water doesn't just sustain life, it consumes the planet itself, slowly, patiently, and without exception. If we zoom out even further, we have to consider the neighborhood. Earth orbits a star that we affectionately classify as a stable yellow dwarf. But stability in astrophysics is a highly relative term. In 1859, the sun sneezed. A massive solar flare, accompanied by a coronal mass ejection, slammed into Earth's magnetic field. This became known as the Carrington event. The impact was so violent that the northern lights, normally confined to the polar regions, were visible as far south as the Caribbean. Miners sleeping in the Rocky Mountains woke up at 1 in the morning and started making breakfast because the sky was glowing so brightly they thought the sun had risen. At the time, humanity's most advanced technology was the telegraph. The solar storm induced so much electrical current in the wires that telegraph operators were physically shocked at their desks, and telegraph paper spontaneously caught fire. If a Carrington-level event were to hit us today, the results would be apocalyptic. The global power grid, woven from millions of miles of delicate copper and aluminum, would act as a giant antenna, absorbing the geomagnetic shockwave. Transformers would detonate. The internet would go dark. The economic damage would be measured in the trillions of dollars. And the recovery time wouldn't be measured in weeks, but in years. And this isn't a hypothetical science fiction scenario. In July 2012, a coronal mass ejection of exactly that magnitude tore through Earth's orbital path. We missed it by a mere 9 days. We are spinning around a thermonuclear furnace that occasionally throws out indiscriminate bursts of planetary-scale destruction, and our entire modern civilization relies on simply not being in the wrong place at the wrong time. And even if we dodge every solar flare, the sun has already written our expiration date. Every billion years, our star becomes about 10% more luminous. In roughly 1 to 1 and a half billion years, that gradual increase in brightness will push Earth's temperature past the tipping point. The oceans will literally boil away into space, long before the sun swells into a red giant and physically swallows Mercury, Venus, and Earth. Our planet will be reduced to a scorched, barren rock. It is a matter of stellar physics. Biology, technology, and hope simply do not factor into the equation. But let's bring it back down to Earth, to the history hidden right beneath your feet. Because the most unsettling thing about this planet is its track record. If you look closely at the fossil record, you will realize it is actually a crime scene. 5 times in the past, the Earth has attempted to wipe the slate clean and kill virtually everything on it. The first time was the Ordovician mass extinction, about 444 million years ago. Roughly 85% of all species vanished. The leading theory is that a sudden drop in carbon dioxide triggered a severe, flash freeze ice age that drained the oceans and locked the world in ice. Though some researchers look at the abruptness of the event and wonder if a gamma-ray burst from a dying star in our galactic neighborhood happened to snipe our ozone layer, baking the surface in ultraviolet radiation. Either way, almost everything died. Then came the late Devonian extinction, 375 million years ago. 75% of life was lost, likely because massive volcanic activity altered the chemistry of the oceans, stripping the water of oxygen and suffocating marine life in a global dead zone. But the third time was the masterpiece. 252 million years ago, at the boundary of the Permian and Triassic periods, the Earth executed what paleontologists quietly refer to as the Great Dying. Up to 96% of all marine species and 70% of terrestrial vertebrate species were erased. The culprit was a region in modern-day Russia called the Siberian Traps. The Earth simply ripped open, and an unimaginably vast volcanic eruption poured out enough lava to cover an area the size of the continental United States. The eruption ignited massive underground coal deposits, pumping apocalyptic amounts of carbon dioxide and sulfur into the atmosphere. The oceans turned highly acidic. The global temperature spiked by 18 degrees Fahrenheit. The marine ecosystem collapsed so thoroughly that the dead, stagnant oceans began to burp massive clouds of toxic hydrogen sulfide gas, which drifted over the land, poisoning the air and destroying the ozone layer. The planet was reduced to a toxic, sweltering hellscape. It took 10 million years just for forests to grow back. The fourth event, the Triassic-Jurassic extinction 201 million years ago, saw more catastrophic volcanic activity tear apart the supercontinent of Pangaea, wiping out another 75% of species. And then there is the fifth one, the one you know, 66 million years ago, a rock roughly 6 miles wide, traveling at over 12 miles per second, slammed into the shallow waters of what is now the Yucatan Peninsula in Mexico. The kinetic energy released in that fraction of a second dwarfed the combined explosive yield of every nuclear weapon ever built by humanity, multiplied by several orders of magnitude. If you had been standing anywhere within 1,000 miles of the impact, the thermal radiation would have incinerated you before your brain even had time to process the flash of light. The impact punched a hole in the crust, vaporizing ocean and rock alike, and throwing millions of tons of pulverized debris into the upper atmosphere. The sky turned black. The sun was blocked out for years. The plants died. The herbivores starved. The carnivores followed. The non-avian dinosaurs, a spectacularly successful lineage of animals that had dominated the globe for over 150 million years, were snuffed out in a geological blink of an eye. 75% of all life went with them. We like to think of asteroid impacts as ancient history, but the universe hasn't stopped throwing rocks at us. In 2013, a meteor just 65 feet across exploded over the Russian city of Chelyabinsk. The shockwave shattered glass across the city, injuring 1,500 people. And the most terrifying part, we never saw it coming. It approached Earth from the direction of the sun, hiding in the glare, sitting perfectly in the permanent blind spot of our planetary defense systems. On that exact same day, an entirely different, much larger asteroid flew past Earth, slipping closer to us than our own communication satellites. We had been tracking that one for a year. We completely missed the one that actually hit us. NASA currently tracks over 35,000 near-Earth objects, but astronomers estimate we have only found about 40% of the city-killer asteroids, the ones around 460 feet wide. In 1908, one of those smaller, undetected rocks exploded over the Tunguska region of Siberia, flattening 800 square miles of forest with the force of a massive thermonuclear weapon. We were incredibly lucky. It exploded over an uninhabited swamp. Had it arrived just a few hours later, the rotation of the Earth would have placed it directly over St. Petersburg. Millions would have died. And as any astronomer will tell you, luck is not a viable planetary defense system. Even the solid ground we walk on is an illusion. The continents are not fixed anchors. They are jagged shards of a cracked, cooled crust, floating on a sluggish, convecting mantle of hot rock. They drift at about the same speed that your fingernails grow. When these massive tectonic plates collide, they crumple upward to form mountains. When they pull apart, they bleed magma. But when they grind past each other, they get stuck. The rock deforms, building up unimaginable friction and pressure over centuries, until the rock finally snaps. The result is an earthquake capable of leveling a modern city in less than a minute. Along these tectonic scars sit roughly 1,500 active volcanoes on land, and countless more hidden in the dark depths of the ocean. And every few tens of thousands of years, the Earth produces a super eruption. About 74,000 years ago, the Toba supervolcano in present-day Indonesia detonated, blasting nearly 670 cubic miles of pulverized rock and ash into the sky. The ash layer from that single eruption can be found in sediment cores stretching from East Africa all the way to the South China Sea. Today, a similar monster sleeps beneath Yellowstone National Park. It is powered by a deep mantle hotspot that has produced 3 super eruptions in the last 2 million years. The magma chamber is still there. It is still active. On a long enough timeline, the math of geology always wins. But the Earth doesn't just use fire and rock to assert its dominance. It also uses ice. Across the Arctic, a thick layer of permanently frozen ground, known as permafrost, covers about a quarter of the northern hemisphere. In some places, this frozen dirt goes down more than 1,000 feet. It acts as a massive planetary deep freeze, locking away the dead, animal carcasses, human remains, and, most alarmingly, ancient bacteria and viruses. But because the Arctic is currently warming at nearly 3 times the rate of the rest of the globe, the freezer door has been left open. In the summer of 2016, an unusually warm heat wave hit the Yamal Peninsula in Siberia. The rising temperatures thawed the 75-year-old carcass of a reindeer that had died of anthrax. The anthrax spores, which had been perfectly preserved in the ice, woke up. They washed into the soil and groundwater, infecting the local reindeer herds. Before it was contained, over 2,000 reindeer died, dozens of people were hospitalized, and a 12-year-old boy lost his life. A 75-year-old frozen carcass was all it took. But 75 years is nothing. In 2014, a French researcher named Jean-Michel Claverie and his team took a sample of Siberian permafrost that was 30,000 years old. Inside, they found a virus. They slowly warmed it up, introduced it to some amoebas, and watched in awe as the virus immediately sprang to life and began infecting the cells. Since then, his team has resurrected over a dozen ancient viruses, including one that is estimated to be 48,500 years old. It is the oldest infectious pathogen ever revived. Now, the viruses they are studying only target amoebas. They are harmless to humans. The problem is the things we don't know about. Researchers have already detected the genetic ghost prints of pox viruses and herpes viruses deep in the permafrost. In northern Russia alone, there are roughly 7,000 shallow burial grounds for cattle and reindeer, many of which contain the frozen remnants of diseases that modern human immune systems haven't encountered in centuries, if ever. And if the frozen north feels alien, the deep ocean is practically another universe. We have mapped the dry, dusty surface of Mars at a higher resolution than we have mapped the bottom of our own oceans. Roughly 80% of the deep sea remains entirely unexplored. Down there, in the pitch black, life has mutated into forms that look like they were pulled directly from a nightmare. There are anglerfish dangling bioluminescent lures in the dark, vampire squids that turn themselves inside out to reveal a cloak of spikes when threatened, and giant isopods the size of house cats, scavenging the abyssal plains. The environment they live in is hostile beyond human comprehension.